Let us compute the mean, variance, and standard deviation of the sampling distribution of the sample means. We can do this in two ways. The first way is when we use the parameters. That is, we calculate first the population mean, the population variance, and the population standard deviation. Or we can use the sampling distribution of the sample means. In this example, we will be using the parameters. Let us have this problem. Samples of 2 cards are drawn at random from a population of 6 cards numbered from 1 to 6. Compute the mean, variance, and standard deviation of the sampling distribution of the sample means. Again, to answer this problem, we will be using the population mean, population variance, and population standard deviation. To do it, we need the following formulas. In calculating for the mean of the sampling distribution of the sample means, which is denoted by mu sub x bar, is we determine the summation of the sample means and we divide it by the sample size for finite population. Likewise in infinite population. While for the variance, to determine the variance of the sampling distribution of the sample means, which is denoted by lowercase letter sigma squared sub x bar, which is equal to, we have here the variance of the population divided by the sample multiplied by n, the population minus the sample divided by the population minus 1. While for, if we have an infinite population, the variance of the sampling distribution of the sample mean is denoted by the population variance divided by the sample. For standard deviation, denoted by lowercase sigma sub x bar, is determined by determining the population standard deviation divided by the square root of the sample multiplied by the square root of the population minus the difference minus n, or the lowercase n, which represents the sample, divided by a population minus 1. That is for finite population. Now, if we have an infinite population, the standard deviation of the sampling distribution of the sample means is simply the quotient between the population standard deviation and the square root of the sample size. Let us answer our problem using these formulas. Now, as what I have said, we will be using the parameters. We will compute first the population mean, the population variance, and the population standard deviation. Now, the problem is that we will be drawing randomly 2 cards from a set of 6 cards numbered from 1 to 6. That is, we have our x values here, 1, 2, 3, 4, 5, 6. And this represents the population. And to calculate for the population mean, mu, we simply add all these x values and we divide it by the population size, which is 6. That is, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6. We have 21 and we divide it by the size of the population, which is equal to 6. And 21 divided by 6 is 3.5. Thus, we have the population mean 3.5. Now, before we proceed to calculating the population variance, we remember the formula that we need to subtract each x value from by the population mean. And we do that in the next column. We have x minus the population mean. We have 1 minus 3.5 is negative 2.5. 2 minus 3.5 is negative 1.5, and so on. And after that, we square the differences. we add another column and we label it as the square of the difference between the x value and the mean. We have negative 2.5 squared, we have 6.25. Negative 1.5 squared is 2.25, and so on. Now, let us proceed to calculating the population variance. Again, let us have this formula, the summation of the squares of the differences between each x value and the mean divided by the population size. That is, we add all the values here, 6.5 plus 2.25 plus 0.25 plus 0.25 plus 2.25 plus 6.25, and we got the sum 17.5. We divide by the population, which is 6, and we got the value 17.5 divided by 6 is 2.917 in 3 decimal places. That is now the population variance. Now is the population standard deviation. We knew that to determine the standard deviation, we get the square root of the variance. Now, we have the square root of 2.917, which is equal to 1.708. We have now the value of the population standard deviation, the population variance, and the population mean. Now, we will be using these values in calculating for the mean, variance, and standard deviation of the sampling distribution of the sample means. Now, let us have the formula. Now, the mean of the sampling distribution of the sample means is equal to the population mean. That is one of the properties of the sampling distribution of the sample means. Always remember that the mean of the sampling distribution of the sample means is equal to the population mean. We have already calculated the population mean, which is 3.5. Thus, the value of the mean of the sampling distribution of the sample means in our problem is also 3.5. Next is, we have to calculate the variance of the sampling distribution of the sample means. Now, we have this formula, and we will just input the given in this formula. We have the variance of the population, which is equal to 2.917, wherein n, the sample, we are going to draw 2 out of 6 numbers. And we have n, the population, which is 6, minus the sample, which is 2, and 6 minus 1. We have 2.917 divided by 2 times 6 minus 2 divided by 6 minus 1. And calculating this, we will arrive at the value 1.167 in 3 decimal places. 1.167 is now the value of the variance of the sampling distribution of the sample means. Now, the standard deviation of the sampling distribution of the sample means is simply the square root again of the variance of the sampling distribution of the sample means, which is 1.167. Thus, to determine the standard deviation of the sampling distribution of the sample means, we determine the square root of 1.167. And using our calculator, we got our square root 1.080 in 3 decimal places. Again, in calculating for the mean, variance, and standard deviation of the sampling distribution of the sample means, we can use the population mean, variance, and standard deviation. Do not forget that the population mean is also the mean of the sampling distribution of the sample means.